Hello! In this project, we will write a sketch that will cause an LED to blink using the Chipkit Uno 32 board. These types of boards interact with the external world through connectors known as pins. Thus, by controlling whether the pin tied to the LED is high or low, we can control whether or not the LED is illuminated. Before you begin, you should work through the Introduction to MPIDE project and learn how to download a sketch, as well as understand the difference between digital and analog signals. MPIDE is based on C++ language, for which you typically have a main function, but in MPIDE, a main function has already been written for you, so all you need to do is write the setup and loop functions. To start, create a setup function, which has no inputs and which does not return anything, so its type is void. Then, within the setup function, use the Pinmode function to tell the board you wish to use a pin in a certain way. This function takes two arguments. One is the pin number, and the other is the mode for that pin, which can be either input for reading signals from the pin or output for writing to it. We want to configure pin 13 for output so that we can write to the LED. Therefore, we use Pinmode 13 and the constant, in this case, output. And let's add a comment for good programming practices. Next, you can write the loop function that will run repeatedly after the setup function until the power is off or until the board is reprogrammed. Type void, loop, open bracket, and then to make the LED blink, you will use a combination of functions. The first is digital write, which requires two arguments. One is the pin to which you're writing, and the second is the state of the pin, which is either high or low. Let's start with high to turn it on. The next function we need to write is the delay function, which is used to specify the amount of time during which the board simply does nothing. Type delay, parentheses, and then include the number 1000, which is in milliseconds. This is equivalently a 1 second delay. And comment. We repeat the writing and the delaying functions again to turn the LED off and add another 1 second delay. Then close brackets. We now have all the code necessary to obtain the blinking LED, and we're ready to upload it. And the LED is blinking as expected. You may like the opportunity to make modifications to the code and change the speed of the blinking by modifying the time delay. Find out how short the delay should be before you can no longer detect it, or try to anticipate what may happen if the delay function is taken away completely. Keep in mind that you will have to upload the new code to your board every time you make a modification. That is all for the creation of a sketch to blink an onboard LED.